Understanding the map function. The Python 2 documentation says, built-in functions, map function, iterable, apply function to every item of iterable and return a list of their salts. If additional iterable arguments are passed, function must take that many arguments and is applied to the items from iterables in parallel. If one iterable is shorter than another, it is assumed to be extended with none items. If function is none, the identity function is assumed. If there are multiple arguments, map returns a list consisting of tuples containing the corresponding items from all iterables, a kind of transpose operation. The iterable arguments may be a sequence or any iterable object. Their salt is always a list. What role does this play in making a Cartesian product? What effect does putting a tuple anywhere in there have? I also noticed that without the map function the output is A, B, C, and with it, it's A, B, C. I want to fully understand this function. The reference definitions is also hard to understand. Too much fancy fluff.
Map isn't particularly Pythonic. I would recommend using list comprehensions instead. Is basically equivalent to. Map on its own can't do a Cartesian product, because the length of its output list is always the same as its input list. You can trivially do a Cartesian product with a list comprehension though. The syntax is a little confusing. That's basically equivalent to.
Map doesn't relate to a Cartesian product at all, although I imagine someone well versed in functional programming could come up with some impossible to understand way of generating a one using map. Map in Python 3 is equivalent to this. And the only difference in Python 2 is that it will build up a full list of results to return all at once instead of yielding. Although Python convention usually prefers list comprehensions, or generator expressions, to achieve the same result as a call to map, particularly if you're using a lambda expression as the first argument. As an example of what you asked for in the comments on the question, turn a string into an array. By array you probably want either a tuple or a list. Both of them behave a little like arrays from other languages. A use of map here would be if you start with a list of strings instead of a single string. Map can listify all of them individually. Note that map list A is equivalent in Python 2, but in Python 3 you need the list call if you want to do anything other than feed it into a for loop, or a processing function such as sum that only needs an iterable, and not a sequence. But also note again that a list comprehension is usually preferred.
Map creates a new list by applying a function to every element of the source. An RE map is equivalent to zipping input iterables together and then applying the transformation function on every element of that intermediate zipped list. It's not a Cartesian product. I've used zip here, but map behavior actually differs slightly when iterables aren't the same size. As noted in its documentation, it extends iterables to contain none.
Simplifying a bit, you can imagine map doing something like this. As you can see, it takes a function and a list, and returns a new list with the result of applying the function to each of the elements in the input list. I said simplifying a bit because in reality map can process more than one iterable. If additional iterable arguments are passed, function must take that many arguments and is applied to the items from all iterables in parallel. If one iterable is shorter than another it is assumed to be extended with none items. For the second part in the question, what role does this play in making a Cartesian product? Well, map could be used for generating the Cartesian product of a list like this. But to tell the truth, using product is a much simpler and natural way to solve the problem. Either way, the result is the Cartesian product of LST as defined above.
The map function is there to apply the same procedure to every item in an iterable data structure, like lists, generators, strings, and other stuff. Let's look at an example. Map can iterate over every item in a list and apply a function to each item, then it will give you back, the new list. Imagine you have a function that takes a number, adds 1 to that number and returns it. You also have a list of numbers. If you want to increment every number in the list, you can do the following. Note, at minimum map needs 2 arguments. First a function name and second something like a list. Let's see some other cool things map can do. Map can take multiple iterables, lists, strings, etc., and pass an element from each iterable to a function as an argument. We have 3 lists. Map can make you a new list that holds the addition of elements at a specific index. Now remember map needs a function. This time we'll use the built-in sum function. Running map gives the following result. Remember, in Python 2 map will iterate, go through the elements of the lists, according to the longest list, and pass none to the function for the shorter lists, so your function should look for none and handle them, otherwise you will get errors. In Python 3 map will stop after finishing with the shortest list. Also, in Python 3, map returns an iterator, not a list.
If you want to support the channel, please consider subscribing.